All right. So now, let's list some information, okay? This shirt, let's list some things. Takes 10 minutes to make. All right? Cost, to make this thing, it costs $4. All right? And I want to make a profit of $6. Yeah, okay. Okay. So now this sweatshirt, this one takes 30 minutes to make. It cost $20 to make, and I want to make a profit of $20.
So you're selling the t-shirt for 10.
Yeah. Now, how many t-shirts do I need to make? And how many sweatshirts do I need to make the maximum profit? Because I'm going to make them. I got to call somebody and I'm going to say, hey, make me so many t-shirts and so many sweatshirts. But there's some other constraints. All right? Here are the constraints, okay? So the constraints in regular terms, and then we'll make equations for them. I only have 20 hours to make them. That's constraint number one. I only have a budget of $600. Okay? Another constraint that I have is that I want to sell at least 50 units. I don't know what they are, but when I called the guy, he said, look, you can order t-shirts, sweatshirts. It doesn't make me any difference as long as you order at least 50 shirts. Right? Because they got to print 50 of one thing or the other. To them, it doesn't matter. You can put a sweatshirt on the screen printer, or you put t-shirt on. Do you have a question? Anybody have a question? Okay. No? Were you stretching? Yeah? Okay. So let's just kind of review. Mr. Adams is making t-shirts for the robotics team. I call them up. They tell me how much time it takes, how much cost it takes. They give me a quote.
Robotarians.
And I say, I only have $600. They say, hey, that's fine. How many t-shirts, how many sweatshirts do you want? I say, I don't know. They say, well, it doesn't matter to us as long as you order 50 combined, total. At least 50 units. I say, okay, cool. Then I go back and I go, man, I want to make the most amount of profit possible. How do I figure out how many t-shirts to order and how many sweatshirts to order, and then I'll just sell that many? You know, how do I do that? Well, I would do this thing. All right? So now I need to make the equations for my constraints. So the first thing I want to talk about is minutes. And so for the minutes, and I'm gonna put this up here a little bit. For my minutes, this is for the t-shirts, and this is for the sweatshirts. So we'll call this X and this Y, because I don't know how many of each I'm going to need. So how many minutes does it take me to make it? A t-shirt?
10.
10 minutes. So 10 minutes per shirt. Right? How many minutes to make a sweatshirt?
30.
30 minutes. So I'm going to say 30 minutes per sweatshirt. How much time do I have total? 20 hours, which is equal to 1,200 minutes. Right? Does that make sense? Total. So now, I need to make sure that my first constraint, 10x plus 30y, is less than or equal to 1,200 minutes. That's my first constraint. Does that make sense to you guys now? All right, good. So now we're going to take this, slide this over a little bit. So then the next thing I need to talk about is the money. Well, actually, the number of shirts. How many t-shirts am I doing? X number. How many sweatshirts am I doing? Y number. What's the total? At least 50. So I would say X plus Y has to be at least 50. So how do you do that with the inequality symbol? Yes?
Greater than or equal to.
Greater than or equal to 50. right? Does that make sense? So then the next thing that I would do is I got to talk about the cost. How much money do I have to spend? $600. How much is it going to cost me? Well, $4 per shirt and $20 per sweatshirt. So I have 4x plus 20y has to be less than or equal to $600. Right? That's my third constraint. You guys with me so far? All right. So now, we're almost there. Oh, lost part of the shirt. All right. So now, last thing I got to talk about, profit. I want to make some money. How much do I want to make per t-shirt?
6.
6 times x. How much do I want to make per sweatshirt?
20.
20 times y. How much am I going to make?
Well, you do the t-shirts plus.
I don't know.
And that's it.
I don't know. So my equation then for profit would be, let me, I don't want to get rid of this, but I want to write it over here. I don't want to get rid of this, but I want to make it smaller. Oh, it's not cooperating with me today. So this is my information over here, and this is my information over here. And let's bring this down over here. So these are my constraints. My profit then would be P. My profit that I need to maximize would be 6x plus 20y. Does that make sense to you guys?
The max might have been what?
Now, there are 2 more constraints. What does x represent?
T-shirt.
T-shirts. What's the least amount of t-shirts I'm going to make?
50.
0. Right? I'm not going to make a -4 shirts. I might choose not to make any shirts, but I'm going to make 0 and up, right? So then my other constraint would be x has to be greater than or equal to 0. How many sweatshirts am I going to make? At most or less?
0 to 50.
Yeah, well, not 50. We don't know yet. I have to do at least 50, but I could do more. Right? So y has to be a positive number 2 or equal to 0. Does that make sense? So those are all my constraints. Now, based on, so all this stuff here, so now what I need to do is I need to take all this information. I came up with this equation. This is, I want to maximize my profit. In other words, I need to figure out what is the maximum number of shirts and, well, not maximum number of shirts. What combination of shirts and sweatshirts give me the maximum profit? So now if I graph this, and we graphed this before, if I graph all of these, if I graph all the constraints, right, these are all my constraints in inequality form, I got this stuff. Then what we need to do is there's a little trick. It's called the pinky method, but because I got it real big on my whiteboard, we're going to call it the hand method. If I plug in 0 for x, isn't that my y-intercept? Yeah? So how can I figure out what my y-intercept is? Because 10 times 0 would be 0, right? 10 times 0 would be 0, so it's like that whole thing goes away when I plug in 0. So how would I figure out my y-intercept?
1200 divided by 30.
What's 1200 divided by 30?
400.
Is it 400 or is it 40?
40.
40. So my y-intercept is going to occur at 40, but I'm going to count by tens. Here's 10, 20, 30, 40. All right? And so let me put this back in here, 10x. So my y-intercept occurs right here. Okay? So now the other thing that I need to do is I could do the exact same thing. I could pretty much pretend that this goes away. And what's my y-intercept?
120.
Or I mean my x-intercept?
120.
120. So if I count by 20s again, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to end up way over there, right? So over here is where I'm going to end up. And I'm going to draw a line between those two. And so I'm just going to actually draw the line. And then we got to determine, so this was 30, whoops. This was 30y, right? All right, so now I got to determine, do I shade above or below? Below. Well, yeah, if I were to solve, it'd be less than, so this needs to be less than 1200, right? So it'd be a little bit below, so we're just going to do this little thing. All right. Now, I probably could draw the line all the way in the other direction like this. Actually, it'd be better to do it like this. Like that. All right, so there we go. Okay, so now if I draw the line like that and it's going below, that's the first constraint. Second constraint. I'm going to do the x is greater than 0, so we'll say x is greater than or equal to 0, right? And so that just means basically I'm going to come down here and I'm going to go greater than 0, which is this side. All right, cool. Then I have another constraint, which is going to be y is greater than 0. Y is greater than or equal to 0. So that's going to go this way, and it's going to be here, above. So I'm already starting to hone in on my feasible region. Remember, they're going to ask me a common solution, and the solution is going to be the vertices of whatever region I have. So now I have two more equations. And so the next equation is I have x plus 5, or I'm sorry, x plus y. Y is less than or equal to 50. Oh, actually greater than 50.
That's in the book, right?
Yeah. I'm just writing them out of order. Yes, question?
How'd you get the black line again?
If I plug in 0 for x, what's 10 times 0?
0.
0. So then I just divide. You know,
Divide, yeah, 4.
Yeah, okay. All right, we're going to do the same thing here. If I plug in 0 for x, it's like this never existed, right?
Wait, but how'd you get your slope?
I don't need the slope. I have the x and y intercepts. So watch me. I'm going to do it again. That's a great question. I'm going to do it again with this exact same problem, right? The y-intercept occurs when x equals 0, right? So y-intercept occurs when x equals 0. Well, when x equals 0, this goes away to 0. So what's my y-intercept? Y is greater than 50. So I got to go 1, 2, 3, 4, 5, and y is greater than that. So uh-oh, somewhere we made a mistake. Did I write something down wrong?
Yes.
Oh no, that's just, that's not what it is. That's just the y-intercept, right? So I'm going to have another line here. Let's use the green. So that I'm going to have my y-intercept is there. So now if I go to find the x-intercept, right? The x-intercept,
0 in for y.
50.
I put in 0 in for y and I get 50 for that. So I'm going to come over here and I'm going to go 1, 2, 3, 4, 5. So this is my x and y intercept, right? Does that make sense?
And you just draw the line.
Yeah. So the x and y intercept for this, right, for this equation are these 2 points, and I'm just going to draw the line between the two. Okay, and then I got to be greater than that value. So that's going to be like, this region. Okay. And then we have one more equation that we have to graph. Let's do it in red. One more constraint would be 4x plus 20y is less than or equal to 600. Again, we're going to use the x and y intercepts to graph this. So the y-intercept occurs, it's like x equals 0, 4 times 0 is 0. What is my y-intercept? 30, right? Because 30 times 20. So my y-intercept is 1, 2, 3. So I got my y-intercept here. Then, if I plug that back in, I've got 4x. To find my x-intercept, my y goes to 0. 0 times 20 is 0. So what's that? That's actually 150, right? So I got to go 1, 2, 3, 4, 5, 6. This was 120, 130, 140, 150. So again, I'm going to draw my straight line between those two intercepts. So I'm going to go from this point here all the way to this point here. All right? And my drawing, and it's less than that, so it's less than that. So here's where it gets really bizarre. You've got your shaded region kind of looks like this, and I'll do a different color. Let's do yellow. No, actually, let's do, yeah, yellow. So I've got this line from here to here, here to here, here to here, and then another one here. And this whole thing is yellow. And you could graph this in your graphing calculator. I just like doing it by hand. So how many vertices do I have? I have a vertex. I've got 1, 2. Actually, no, it kind of goes, yeah. Yeah, it goes like that. And then from here to here, and then here to here. So I've got 1, 2, 3, 1, 2, 3, 4, right? Is that right? So now here's the weird thing. If I label this A is actually, what is that, 50, 0? And if I label this one B, I think that's 20, well, it's a little bit more over here. So it'd be 1, 2, your book says that it's 25, 25. And then for C, we actually have got 75. If this was C, it would actually be 75, 15. And then for D over here, D would be the point, 120, 0. If I graphed all this stuff, I got 4 points, A, B, C, and D. And those are the vertices of what we call the feasible region. And since my equation was P is equal to 6x plus 20y, I need to pick out A. So I would say P of A is equal to 6 times 50 plus 20 times 0. Well, P of A is what? 300. Okay, now I do P of B. P of B would be 6 times 25 plus 20 times 25. All right, and P of B would be 650, isn't it?
650.
Isn't that what I just said? So P of B would be 650. All right, so now if I do P of C, I would plug in 6 times 75 plus 20 times 15. That would be 750. And then P of D would be 6 times, what was it, 120? 120 times, or plus 20 times 0. right? And so P of D, I ran out of room there, P of D equals 720. So which one's the maximum value? C, right? So C gives me the maximum profit. What does that tell me? It tells me I need to make how many t-shirts and how many sweatshirts?
75 and 15.
So if I make 75 t-shirts and 15 sweatshirts, and I sell that many t-shirts and sweatshirts, I'll make the maximum profit.
When